Hey everyone, it's Miss Joyce. Today we'll be learning how to add and subtract mixed numbers with unlike denominators. Let's start with 3 and 2 fifths plus 2 fourths. The first thing to notice is that our denominators, 5 and 4, are not the same. We need to create equivalent fractions so that they have the same denominators. To do this, we're going to list out our multiples of the denominators 5 and 4. We have 5, 10, 15, 20, and 25. For the multiples of 4, we have 4, 8, 12, 16, and 20. Now we're going to look at both lists, and we're going to find a number that we can find in both of these lists. We see the number 20. So that is going to be our common denominator. We are going to rewrite each of the fractions so the denominator is 20. Let's start with 3 and 2 fifths. We are going to make an equivalent fraction where the denominator is 20. So we're asking ourselves, what do we multiply by 5 to get to 20? Well, 5 times 4 equals 20. Since we're multiplying by 4 on the bottom, we need to multiply the numerator by 4. 2 times 4 is 8. The whole number 3 stays the same in the front. So 3 and 2 fifths is equal to 3 and 8 twentieths. Next, we have 2 fourths. We are going to rewrite this so that the denominator is also 20. Let's ask ourselves, what do we multiply by 4 to get 20? Well, 4 times 5 equals 20, so we want to multiply by 5 on the top as well. 2 times 5 is 10. So 2 fourths is equal to 10 twentieths. We've now created our equivalent fractions. So we need to add these fractions together since our starting problem was addition. 3 and 8 twentieths plus 10 twentieths. Let's start by adding the fractions. 8 twentieths plus 10 twentieths is equal to 18 twentieths. Now we can add the whole numbers. There's no whole number in front of 10 twentieths, so that is like a 0. 3 plus nothing is equal to 3. So our sum or answer is 3 and 18 twentieths. Now let's try a subtraction problem. We have 2 and 5/6 minus 1 and 2/3. First thing we can notice is that the denominators 6 and 3 are not the same. So we're going to have to create equivalent fractions where the denominators are the same. To do this, we are going to list out our multiples of both 6 and 3. We have 6, 12, 18, 24, and 30. For the denominator 3, we have 3, 6, 9, 12, and 15. Now we're going to look at both lists and see which number is found in both lists. I'm going to circle the number 6 because that is the smallest number that can be found in both lists. But you'll notice there's also the number 12. You could use the number 12 as your denominator. Your numbers are just going to be bigger. So now we're going to create equivalent fractions where the denominator is 6. With 2 and 5/6, you'll notice that the denominator is already 6. So we can just rewrite this, keeping the same denominator of 6. Since the denominator stays the same, our numerator will stay the same. Our whole number in the front, 2, always stays the same. 2 and 5/6 is equal to 2 and 5/6. Now we have 1 and 2/3. Here, we have to rewrite this as 6. So we ask ourselves, what do we multiply by 3 to get to 6? Well, 3 times 2 equals 6. So we're going to multiply by 2 on the top. 2 times 2 is 4. The whole number 1 stays the same. Now we have our equivalent fractions where the denominators are both 6. We need to subtract these because our starting problem was subtraction. So we have 2 and 5/6 minus 1 and 4/6. Let's start with the fractions. 5/6 minus 4/6 is equal to 1/6. Don't forget about the whole numbers. We have to subtract those as well. 2 wholes minus 1 whole is equal to 1 whole. So our answer is 1 and 1/6. Now let's try an addition problem that's going to involve some regrouping. Same thing, we need to look at the denominators. They are not the same. So let's list out our multiples of both 4 and 3. we have 4, 8, 12, 16, and 20. For 3, we have 3, 6, 9, 12, and 15. We're going to look at both lists to see which number can be found in both of these lists, and we see the number 12 can be found in both lists. So we are going to rewrite each of these fractions so that the denominator is 12. Let's start with 2 and 3/4. We're going to read the denominator as 12. Let's think, what do we multiply by 4 to get to 12? Well, 4 times 3 equals 12. So since we're multiplying by 3 on the bottom, we need to multiply the numerator by 3. We can see that 3 times 3 is 9. The whole number 2 in the front stays the same. Let's do the same with 1 and 2/3. Again, we're going to rewrite this as 12ths because we circled the number 12 in both of our lists. Let's think, what do we multiply by 3 to get to 12? Well, 3 times 4 equals 12. So we're going to multiply the numerator by 4. 2 times 4 is 8. The whole number 1 in front stays the same. Now that we have our equivalent fractions, let's add them. 9/12 plus 8/12 is equal to 17/12. Let's now add the whole numbers. 2 plus 1 is 3. So our sum is 3 and 17/12. But you'll notice the numerator on top is bigger than the denominator on the bottom. So that means that this fraction is greater than 1. We can take at least one whole out. So we're going to do that on the bottom here. We have 3 and 17/12. We can break this apart so that we have 3 plus, now let's take out one whole, which is equal to 12/12. And we're thinking, if we take out 12/12, what do we have to add to get to 17/12? Well, 12/12 plus 5/12 will get us those 17/12. We can rewrite this 12/12 as one whole. Now we just have to add. 3 plus 1 gets us 4, and our leftover fraction is 5/12. So our sum, or answer, is 4 and 5/12. Finally, let's try a subtraction problem with regrouping. We have 3 and 1/4 minus 1 and 1/2. We can see that the denominators are not the same, so we're going to list out our multiples. We have 4, 8, 12, 16, and 20. For the denominator 2, we have 2, 4, 6, 8, and 10. When we look at both of the lists, we can see the number 4 can be found in both lists. You could also use the number 8 if you'd like, but I like to use the smallest numbers to keep our numbers simple. So let's create equivalent fractions where both denominators are 4. You'll notice with 3 and 1/4, our denominator is already 4. So when we rewrite it, we can keep everything the same. 4 times 1 is 4, so 1 times 1 is 1. The 3 in the front stays the same. With 1 and 1/2, we can rewrite this as fourths. We say, what do we multiply by 2 to get to 4? Well, 2 times 2 equals 4, so let's multiply by 2 on the top. 1 times 2 is 2. We'll keep the whole number 1 in the front the same. Now we can subtract. We always start by subtracting the fractions first. You'll notice we have 1/4 minus 2/4, but we can't do that the way it's written here. We can't do 1 minus 2 without regrouping. So we need to create fractions greater than 1 or improper fractions so that we can actually subtract these fractions together. So what we're going to do is we are going to rewrite 3 and 1/4 so that the numerator on top is larger. To do that, we multiply the denominator 4 times the whole number 3. 4 times 3 is 12. And then we add the leftover numerator 1. So we had 4 times 3 is 12, plus 1 is 13. The denominator 4 stays the same. 13 is our numerator. We're going to do the same thing with our second fraction. We have 4 times 1 is 4, plus 2 is 6. So our numerator is 6, our denominator 4 stays the same. We're now able to subtract these fractions. We have 13 fourths minus 6 fourths gets us 7 fourths. But you'll notice the numerator is larger than the denominator, so that means we can take out at least one whole. So we can say here, 7 fourths is equal to 1 3/4. If we wanted to check our work, we could say 4 times 1 is 4, plus the numerator 3 is 7, which is what we started with. So our answer is 1 3/4.